Hello, this is Mr. Bainey, and we're going to take a look at lesson 4.3, Modeling Arithmetic Sequences. The essential question is, how can you solve real-world problems using arithmetic sequences? So let's first take a look at this Explore, and we have watermelons that are going to cost $6.50 each at the local market. The total cost in dollars of n watermelons can be found using C of n equals 6.5 times n. So when we use that function, we'll be able to complete the table of values. One watermelon we know is going to cost $6.50. Two watermelons is going to cost $13. And three watermelons will cost $19.50. And 4 watermelons will cost $26. So the common difference is how much is being added for each consecutive number of watermelons, and that is $6.50. And what does n represent in this context? And it does tell you that in the situation, it describes it's the number of watermelons. Part D, what are the dependent and independent variables in this context? So our independent, remember, is n, and that represents the number of watermelons. Same thing as part C. And what depends on the number of watermelons? It is the C of n. And in the context, it is the cost. And lastly, we want to look at what C of 7 is. So we're going to take C of 7 is equal to 650 times 7. And that's going to give us, see, 42, so it's $45.50. And this means, so it's asking what does this value represent, and it represents 7 watermelons cost $45.50. Okay, so you'll have to keep in mind that we're working in a real-life situation here. Still be able to find the common difference, identify what your independent, dependent variables are, because that's going to be important in understanding the function, and then be able to interpret certain values of the function, especially using the units, right, from our variables. Okay, let's take a look at some more examples. So I'm going to go to the Your Turn at the bottom of page 176. Construct an explicit rule in function notation for the arithmetic sequence represented in the table. Then interpret the meaning of a specific term of the sequence in the given context. So for number 2, we have a table here. It shows the distance in miles, that's f of n, from the store after Mila has traveled for n hours. So our hours is going to be our independent variable, and our distance in miles is our dependent. So the number of miles depends on the number of hours. So let's write our explicit rule for this sequence, for this function. So we can see that our time is going by ones, right? So they are consecutive terms. Our terms are 20, 32, 44, and 56. So I know that my common difference is just taking any term and subtracting the previous one. And when I do that, I'm going to get 12. So I know that f of n, so I'm writing my explicit rule now, is equal to my first term. And our first term, remember, is this where n is 1. So that's 20. And then my common difference, I'm going to be adding 12. And then we're going to write down how many times we're going to be adding 12. It depends on n, right? So it's going to be n minus 1. There is another way to write this function. and they're both equivalent to each other, you could write f of n equals 8 plus 12 times n instead. So if you're interested in how I got that one, you can come in and ask me that question. So now we need to figure out what is f of 10, and then what does it represent? So f of 10 equals 20 plus 12 times 9, right? Because that's 10 minus 1. And then that becomes 20 plus 108. And finally, 128. So this is going to mean that Mila is going to travel 128 miles in 10 hours. Okay. Number 3, your turn. We have a table that shows the cost in dollars of purchasing N battery packs. We have the same directions here, which is to write the explicit rule. Then we're going to find the value of a specific term and then interpret it as well. So the number of battery packs is our independent variable. The total cost is going to depend on the amount of battery packs. So again, we notice that our n goes in order. It's consecutive, which means our terms at the bottom are going to also go in order and should be arithmetic, which means we have a common difference. Our common difference we'll find out by taking $8.90 minus $4.90, okay, which is $4. We're adding $4 every single time we add a battery pack. So my function is going to look like this. Oops, that's the wrong one. So I have f of n equals $4.90, because that's for one battery pack, plus I'm going to add $4 times n minus 1. And again, since I showed you on the last one, another alternate function that we could write is f of n equals 0.90 plus 4n. So if I want to find f of 18, I'm going to be doing $4.90 plus 4 times 17. And so instead of finishing this off, because you could just do 4 times 17 and then add $4.90, I'll let you finish that. And this represents 18 battery packs cost whatever the output is. Okay. Now let's take a look at our next example. Number 5, construct an explicit rule in function notation for the arithmetic sequence represented in the graph and use it to solve the problem. The graph shows the height in inches of a stack of boxes on the table. As the number of boxes in the stack increases, find the height of the stack with the 7 boxes. Okay, so again, I'm going to look at my points here. It is showing consecutive terms because I have x here is 1, x is 2, x is 3, and x is 4, which means these terms are all consecutive terms. So I could write this sequence like this, 34, 51, 68, 85, dot, dot, dot. And then from there, I'll be able to write the explicit rule. F of n equals my first term plus our common difference. Now, I didn't actually write down how to get the common difference. I forgot to do that. So we calculate common difference by doing 51 minus the previous term, right? Second term minus the first term. And it looks like I get 17. And that's times n minus 1. And then I want to find the height after we stack 7 boxes. So it's going to look like this. And I'll let you finish it off from there. But it'll be 34 plus 17 times 7. And this is going to represent the height, right? Once I do the 17 times 7, and in fact I actually did that wrong. Instead of 7, it's got to be 6. So I got to do 17 times 6, then add 34, and that output is going to represent the height from 7 boxes being stacked. Okay, so be able to write that in a complete sentence once you arrive at that solution. Number 6. Before I go over this, if you are watching this video, first of all, thank you so much for watching. If you are listening to this right now, you can come up to me. I'm going to give the first 5 people who are listening to this to ask me for some PBIS points, and I will give you some there right on the spot. Just bring me your ID card or your agenda, and I'll give you some points right away. So we have Quinn. Begins to save the same amount of each month to save for a future shopping trip. The graph shows total amount she has saved after each month end. What will be the total amount Quinn has saved after 12 months? So again, this is similar to the last problem. We have consecutive terms here because the x's go in order. So my terms are 250, 300, 350, and 400. And that means that so without showing much work here, and by the way, if you're doing a quiz or a test, showing some extra work like calculating the common difference and things like that could potentially give some partial credit because of you're showing your thinking. So always a good idea. But I'm going to not show everything here. I got f of n equals my first term plus our common difference is 50 times n minus 1. And then we want to figure out the total amount that Quinn has saved after 12 months. So after 12 months, we've got 250 plus 50 times 11. And let's go ahead and work this out. It's going to come out to 250 plus 550. And that is about, or not about, but exactly $800. So this is going to represent $800 saved after 12 months. So just to recap our last few examples, we did writing an explicit rule from a table of values, and now we've done a couple examples where we're doing it from a graph. Okay, same process. We're still writing the explicit rule and doing some, or finding some specific term that it's asking us to find. Okay, and your turn number 7. Construct an explicit rule in function notation for the arithmetic sequence represented and use it to solve the problem. Justify and evaluate your answer. So Ruby signed up for a frequent flyer program. She receives 3,400 frequent flyer miles for the first round trip, and she takes 1,200 frequent flyer miles for all additional round trips. How many frequent flyer miles will Ruby have after 5 round trips? So since we have to write an explicit rule, we want to identify again the first term and then our common difference. Okay, so it looks like it says after 5 round trips. Round trips is going to be our independent variable because the number of frequent flyer miles is going to represent our dependent variable. It depends on the number of round trips. So my dependent variable, we just use f of x, that's fine, or f of n, doesn't really matter. But I'm going to do f of x equals, we're starting off with 3,400, right? Because it says that's the amount for the first round trip. And then it's 1,200 frequent flyer miles for all additional ones. So I have to take that times, and I made a mistake. It actually has to be x minus 1, right? Because I used x in my, at the beginning, I wrote f of x. Then, if I want to figure out the amount of frequent flyer miles after 5 round trips, I write f of 5 equals 3,400 plus 1,200 times 4, right? Because that's 5 minus 1. Then continuing over here on the right, f of 5 equals 3,400 plus 4,800, and then I'll get 8,200. frequent flyer miles, and just abbreviate it. So this means 5 round trips will result in 8,200 frequent flyer miles. And number 8, last one. A gym charges each member $100 for the first month, which includes a membership fee, and $50 per month for each month after that. How much money will a person spend on their gym membership for 6 months? So let's go straight to writing our explicit rule. F of x, the first month is going to cost $100. So we can clearly see that the amount charged is our dependent variable, and it depends on the number of months, because it's going to be $50 per month after that. So a difference here you could see is that they're actually telling us the common difference, whereas before we had to find it. They don't tell us that right away. So 100 plus 50 times x minus 1. And then after 6 months means I'm going to change my input to 6. And then it becomes 100 plus 50 times 5, which then leads to, let's just go right to the solution, that 6 months will cost, okay, and I didn't quite work this out yet, but 50 times 5 is 250, then plus 100 will be $350. Okay. And there you have it. That is lesson 4.3. Thank you so much again for watching. Have a great day.